Let's put some of these principles we talked about to work and take an example of designing a system to keep track of the top selling items on an e-commerce website. Might look familiar. This is actually an interview question I used to throw at people when I worked at Amazon as a hiring manager myself, and it was a good way of seeing if people could wrap their heads around large distributed problems and how they would approach them. So all we want to do is create a system that keeps track of the 10 best-selling items on an e-commerce website over time. And what kind of separated the really good candidates from the not so good candidates is they immediately would ask, well, what does it mean to be best-selling? Over what period of time is that considered to take effect over? Is it the 10 best-selling items since the beginning of when this store opened? Is it the 10 best-selling items from the past week, the past hour, some combination of all that? So anyway, once you know those parameters, you might start to think about the problem in the right terms. So if I'm talking about keeping track of the top sellers over a sliding window of time, you should start to think in the back of your head, well, maybe some streaming solution that has sliding windows might be appropriate. And we've talked about a few of those throughout this course. But let's not get ahead of ourselves. We should work backwards from the customer requirements. So let's start off by figuring out what we need to deliver at the end. We know there are millions of end users for this particular website, and they are generating thousands of queries every second. So whatever system we build, when it's vending the end result information to our web servers, it has to be fast. Page latency is very important. People don't want their website to be slow. So at the end, we're going to need some distributed NoSQL-y kind of solution for actually vending the data that we come up with to the website itself. And the access pattern is going to be very simple. It's just going to be, give me the current top end sellers, top 10, top 20, whatever it might be, in this particular category, books or apparel, whatever it may be. So you can see that information can be boiled down to a relatively small data set that can be distributed through some distributed quick database. Hourly updates probably good enough. People don't really care if some new hot item came out and you're not reflecting that in your top sellers instantaneously. But, if some popular new book gets released, people would probably expect to see that within an hour or so. So let's say that hourly updates are probably good enough as far as our customers are concerned. Now, it's easy as a manager to say, no, that's not good enough. I want up to the second results. But again, work backwards from what your customer expects. Your customer does not need up to the second timeliness on this data for the way that this feature is being used. So that means that consistency is not hugely important. As new sales come in, my system does not need to reflect that result immediately. So that informs our choice of database. However, it must be highly available, because if this server goes down, if this service goes down, my website is going to be timing out trying to talk to it, and that's going to slow my website down. And customers do not like broken websites. So I know I'm going to value availability over consistency, and partition tolerance is a given just because of the quantity of transactions we're looking at. The data itself isn't that big, but there's so much traffic going to this data that we're going to need to distribute the processing and vending of that data somehow. So when we talk about databases that value availability and partition tolerance over consistency, well, if you remember, Cassandra was one such beast that did that. And maybe you have some similar solution internally. For example, Amazon's DynamoDB has a similar design as well. But that would be our ideal choice of database. And again, cheat to win if you need to. The reality is the CAP theorem doesn't mean what it used to be. These different database solutions like Cassandra, Redis, MongoDB, HBase, they're all pretty close to each other in terms of availability and partition tolerance. And in the case of Cassandra, it even has adjustable settings for how consistent you want it to be, right? So it's not going to be the end of the world if you have an existing HBase installation or an existing MongoDB installation and a team of people who are experts in MongoDB or whatever it may be. If that's the case, then I would seriously consider using that instead. Be flexible. All right, so in the spirit of working backwards, we've talked about the database layer that's actually vending the top seller information to the web servers, but let's go back one layer earlier. So how is data getting into Cassandra? Well, let's think about things that can talk to Cassandra. Spark is one of them. And we had talked about earlier that this problem really boils down to computing stuff over sliding windows of time over some, increment time. And that's something Spark Streaming can do. So yay. And again, if you were thinking about something other than Cassandra, other options might open up, such as Storm or Flink, and that's okay too. they can fit the bill just fine as well. And again, it comes down to what you're familiar with. You don't want to spin up a whole team on a whole new technology they've never seen before if you don't have to. But Spark Streaming so far fits in nicely with what we're trying to do here. So how does data get into Spark Streaming? Well, you need some sort of a streaming solution to get sales data in as it comes in. So either Kafka or Flume could work just fine. If you were building something explicitly on top of HDFS, you might lean toward Flume since it's purpose-built for HDFS, but so far we haven't really mentioned a requirement for HDFS or even Hadoop at all. Spark can run on a standalone server or it can run on Mesos or something else. And Cassandra has its own little world as well where it stores things on its own as well. So nothing really pushing us toward Flume here. It's still an option if you guys have some internal expertise in it. And it does offer some ways to cheat a little bit. Again, cheat to win. Flume has a nice little log4j interceptor on the server. So if your purchase data is coming from a system that uses log4j, it might be pretty easy to integrate Flume into it. So again, go for the path of least resistance whenever you can. Kafka can totally fit the bill as well, though. Don't forget about security. Purchase data is very sensitive. The information about who is buying what, that can be very sensitive information. So make sure you get a security review on a situation like this. Think about the personally identifiable information that's going to be flowing around on the network for any sort of system you build. And anytime you're dealing with personally identifiable information, you are probably going to need to think a lot about security and protecting the privacy surrounding that data. Now, the best way of dealing with this is to just not deal with the data in the first place. So in this instance, you don't really need to know who actually bought things. You just need to know that something was bought, right? So if there's a way to strip out all of that personal information before it even gets into your system, great. Then it's not your problem. And that's probably something you could do in this case. However, I would still recommend getting a security review of some sort if that's something your organization can offer you. So what have we arrived at? Something like this might work. So maybe we have some sort of a service internally that processes purchases. And as these servers log purchases that happen, maybe I can process that data through Flume and use that to actually get the events across of somebody purchased this thing. And Flume, as you recall, depends on Zookeeper to keep itself running reliably. And then from Flume, I can pipe that data into Spark Streaming, which can be running continuously to calculate the actual top sellers for each category over a sliding window of 1 hour or whatever time we choose. Maybe it's something a little bit more complicated even. That's the beauty of using something like Spark Streaming. You can write code to do more complicated things there. And once Spark Streaming has come up with the results of what the current top sellers are for each category based on the past hour of data, it can dump those results into Cassandra or something similar, where that data then just gets vended to your web application servers who are just asking the question, when a web page is being rendered, what are the top sellers for the category that I'm in? So this would be a perfectly good solution for solving this problem. And again, there is room for interpretation here on the specific components you use. And I also want to make a note of these boxes aren't just one box, right? These represent entire clusters. So Cassandra, that's an entire cluster of machines vending that data. Your web application servers, whole cluster of itself. Spark Streaming can be running on any cluster you want. And you don't even need Hadoop for that. Like I said, Spark Streaming has a standalone server mode you could use. It can run on Mesos, but if you have Hadoop internally, great, run it on top of Hadoop in Yarn. Flume, ditto, you can run on its own server, on its own fleet as well. So don't be misled by how simple this looks architecturally. In reality, these are all entire clusters of their own. But the beauty of this whole system is that it can be easily understood in such terms. Now, I do want to reiterate, there's more than one way to do it. There's no right or wrong answer. I've just given you an example of approaching the problem and how it might lead you towards specific architectural decisions. But again, choose the path of least resistance whenever it makes sense. If you have in-house expertise to leverage, use it. If you have existing systems you can leverage, use them. And think again about the future use of this information. So if I knew that people would want to use this data for analytical purposes as well, maybe I might consider storing this data not only in Cassandra, but also in HDFS, where people can more easily get at it through things like Hive. Or maybe I could slap another layer on top of Cassandra for doing analytical queries, something like Drill. Or, for Cassandra, I suppose we'd be talking about Presto. And you might even consider having a separate replicated Cassandra instance that are dedicated to analytical queries. So that would be a good way of handling that sort of a requirement. So, that's something you just want to think about, that sort of a thing. In that example, that's something you could add on later. Just make sure you have a path to get there if you need to. Okay. So there you have it, an example of applying some of the technologies we've learned about, putting them together, and solving an actual problem. I mean, websites really do need to keep track of top sellers and show them to their users, so I hope that was useful.